With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
The question given here is the ratio of pH of solution 1 containing 1 mole of sodium acetate and 1 mole of HCl and solution 2 containing 1 mole of sodium acetate and 1 mole of acetic acid and 1 liter is. So we have to derive here the relationship between the two pH values here. So let's consider both the cases one by one. When we are considering the first case, we are provided here with the sodium acetate, that is CH3CONa, which is reacting with the HCl. So what would be the reaction here? We will get the acetic acid, that is CH3COH, along with the molecule of NaCl. Okay, we can consider that 1 mole is given in both the cases. So initially 1 mole of sodium acetate and 1 mole of HCl is present, and 0 moles of products would be present here. Okay, so after completion of this reaction, then what would be left with the reactants? We will be left with the 0 moles of reactants and 1 mole each of the products here, isn't it? So in the final solution, we are here with the acetic acid and NaCl. Okay, acetic acid is a weak acid, so how it will dissociate? Feebly only. So it will give few H plus ions and will be in equilibrium with the acetate ions and the H plus ions here. Okay, and NaCl being neutral in solution, so we won't be seeing it. Now, let's calculate the H plus ion concentration in the solution, which we finally got. That would be equal to under root K C, where C is the concentration. But here everything is 1, volume is 1 liter and moles used are 1 liter, so we can put C is equal to 1. Okay, as we know the C is equal to N by V. This is the formula. Now, let's H plus ion is given as under root K. In this way we can calculate the pH of solution. So pH of solution would be minus log of H plus ions. Okay, so put the value of H plus ions here that we have calculated, that is under root K. So minus log, that is under root K. Now we can put this half as the power and keep it in front. Okay, then minus half log K. Now you can see here that the dissociation constant, or whether you can write it Ka only, then the dissociation constant of acid. Okay, so we can write in place of it, that is half pKa. So pKa is equal to minus log Ka, and that is equal to pH or pH 1. So that became our first expression, that is the expression for pH 1. Now let's see the second case given here, in which the buffer solution is given here. Okay, in the second case we are preparing a buffer solution which is acidic in nature. So can we use this formula, that is for buffer solution, where pH is equal to pKa plus log concentration of salt, then divided by concentration of acid. Okay, now again we came to the concentration, and the concentration is 1, isn't it? So putting the log 1, that would give us the value that is 0, because we know that the log 1 is equal to 0. So here we got the new derivation, that is pH2 is equal to pKa. Okay, now let's compare both of these expressions here to find the ratio of pH1 to pH2. Now we can write here that pH1 divided by pH2 would give us, that is pKa divided by 2 into pKa. As the same acid is present in both the situations, so what we can say, that it would be equal to half. So our ratio took the form of half to. So let's see which of the options is giving us this value. So option A is the correct answer.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.